So in this video, what we're going to be looking at is basic introduction to recurrence. Now to start with, what we've got to really look at here is sequences. And in sequences, it's really just a list of numbers written down in succession. So we can have like a random set of numbers. This is no rule to it, but that's what we'd call a random sequence here, as shown sort of there. But what we're looking to and getting used to is this idea of something that's a bit more rule-based. As you can see in this set here, there's a rule. It's +2. So there's a rule to what we're doing. We're going to add 2 to each number. So, and that's what we see here. Now, here's an example where we're going to generate a sequence of terms recursively. So recursively means I'm going to use a previous number, and then use that rule, then use that rule on that previous number, etc., etc., etc. So, for example, write down the first 5 terms of a sequence, starting with this starting value of 6. That's our first number, and then we're going to add 4 to each term. So we're going to go get our second number because it's 6 plus 4 give me 10. Then I'll get the 10, use it here. It gives me 14. And that's the third number. The fourth number is going to be 14 plus 4 gives me 18. I'm going to use that again. That's the fifth number there. So 18 plus 4 gives me 22. So that is my first 5 numbers. And that's that recursive nature. I'm using the previous number to work out a new term based on the rule set I've been given. Here's another set here. Write down the first 5 terms of sequence starting with a value of 5 here. And that's going to be my first number. And the rule is double the number and then subtract 3. So I'm going to double 5, subtract 3. So that's 2 times 5 equals 10 minus 3 gives me 7. So that's my second number. I use that there. So 2 times 7, I'm doubling it. Gives me 14 minus 3, 11. Third, then I go 2 times 11. You see, I'm using that 11 there. That's the fourth. And I get 19. Use that there, apply the rule as I've got here, and use that fifth number. So there I've got 5 numbers, okay? So we can actually use a calculator to do this, and this is, I'm just going to show you on here rather than actually showing the calculator. I might show in calculator for a different one in a different video. But for the moment, the idea is I press, as it says here, use a calculator to generate the first 5 terms of the sequence. For starting value 5, then I've got this rule. So when I do it on the calculator, I type 5, press enter. Then I'll do my rule. So it's going to be 5 because that's my previous term, 5 times 2 because that's doubling, minus 3 because that's subtract 3. So that's where you've got whatever your number here times 2 minus 3. Okay, that gives me 7. Then I go bring that 7 here. The calculator will do this for you. It'll bring the 7 down, it'll times it by 2 and subtract 3, give you 11. And you just go enter, enter, enter. And that's all you need to do, okay? So I'm going to go on to recurrence relations here. A recurrence relation is a mathematical rule that is used to generate a sequence. So in financial business maths, a lot of the focus is on recursion. So recursion always has a starting point, very important, and it has a rule. And for when we get into like simple interest stuff like that, you'll see that being used a bit more. And the examples given here sort of reference that notion of what you'll see in simple interest. Okay, so in this case, the recursion rule is 10, 5, not the rule, the pattern is 10, 5, 20, so I should say sequence. You can see that I've got a starting point of 10. That's my first number. That's my starting point. Let's actually do that, and I'll put a yellow. So that's going to be my starting point there, so we can use the same color. And to obtain the next term, add 5 to the current term and repeat. So then I'd go 15 would be my current term. Then I add 5, and I'll get 20. Then 20 become my current term. Blah 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 blah, etc. 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 Rather blah blah. So this gets sort of hard sometimes to read. So what we actually use is what's actually in there is this symbolic form. And when we get to the financial stuff, this is where we use this VN, and we use something called VN plus wound down here. Okay, so let Vn be the term in a sequence after n iterations. Okay, now what we're going to look at here, using the definition, we proceed to translate our rule written words into a mathematical rule. So our V0 is V0 equals 10. That's where n is 0. That's my starting value. And then I'd write Vn plus 1. So Vn, okay, is that number. You've had the iteration. So if you had no iterations, it's 10. That's what that's referring to here. So after 0 iterations, my value is 10 because I haven't done anything else. This is my starting value. All right. And then it's plus 5. So whatever my Vn is, I put 10 there. I go 10 plus 5. I get 15. So that means that's 0. That goes a 0 in there. So it becomes 0 plus 1. So the V1. So the V1 will be 15. Okay. And then I'd go so just to give you a quick example, so I go Vn plus 1 equals Vn plus 5. I say, so 0 plus 1, even if you write it like that, if you have to make it clear for you, V0 plus 5. So that's V1 equals, what did I say? That was 10 plus 5. So now I can go, if I want to go and now I'm going to say V1 plus 1, because I now know V1. So that should have been 15 like that. Plus 5. I can now get this and bring that down to here. And that'll give me 15. So V2, 15 plus 5 equals 20. And then I'd sort of rinse, repeat. Okay. And this example here is pretty much what they're showing that for. Okay. So they're telling you that the V0 is 9. My starting value is 9. So that's where your V0 9, and you can see that they've put the 9 in there, and they get 5. So then they take the 5 and use it here for V1 to give you V2, and that'll give you an answer of 1. Then they bring the 1 and use that to work out V3, and that gives you -3. Okay. Then use that -3 to give you -7. Then you could use it for the next term, next term, the next term, and next term. Okay. That's the idea. That's what generating a sequence from a recurrence relation means. Again, this is how you can do it on the calculator, where your V0, that's your starting term, goes here. And then, again, this is where you just go enter, 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 enter. So, but I want to just be clear that it's using this 300 there. That's what the calculator actually do for you if you just type 300 to start with and press enter. And then you're going to go get the 141, that gets used by it. So 61.5, and I won't do all of them because I'm going to run out of colors. And that's how that sequence works. So it's using that 21.75, and it's using the rule. It's doing the sequence of operations on that number, and it's giving 1.875, and then I'll do that again and again and again. Okay. All right. So that is it for this one, and I'll see you on the next one. Thanks.